We're going to start with leveling up your custom rules. If you have any questions during this presentation, please ask them right away. Just raise your hand in the webinar or send a message in the chat. We'll be sure to answer your questions as we go along so that we are not dropping too many questions at the end, and make sure that we get you following along with the information that we are presenting here. So KiCad has a very detailed, very comprehensive custom rule set. These are used in circuit layout in order to enforce specialized conditions that you require for your designs. And you can use these to enhance or modify not only the DRC rules, that the implicit DRC rules that you can specify using the board constraints, but also you can use them to modify some of the behavior of KiCad during routing or during zone fill actions. So, and I'll specify which ones exist where, and hopefully clear up some of the confusion around this. So, to begin, custom rules. If KiCad doesn't let you do it by itself, you should write a rule and tell KiCad what you want to do, and it will follow you. What are these custom rules? These are DRC. On the left here, you see the beginnings of what a rule could look like. So a rule might have a condition or a constraint, specify a layer or severity. This is maybe DRC, but maybe not, because as I said, we can sometimes modify the actual behavior of what we see in KiCad as we go along with these custom rules. So to know, is this rule a DRC rule? So if it affects a zone fill, is probably not DRC. It's probably going to change the behavior of KiCad itself. And if it doesn't affect its zone fill, most of these are going to be DRC. So a DRC just means that when you run your DRC check, it's going to pop up an error if something on your layout, on your board, does not match the rule set that you have written. So some examples here. Here, what we're looking at are the pad properties. So when you look at the pad properties, you have some things that you can change using custom rule sets. And down on the bottom, you see the connection to the copper zones. So how the pad connects. Does this connect by a solid fill? Does this connect by thermals? Does it have no connection at all? What kind of zone knockout do we have, and what are the spoke angles for the thermal relief or the thermal gap? And all of these parameters can be modified by custom rules, and you can modify these so that specific footprints have different parameters or specific classes of footprints, maybe pads that connect to a power net should have thicker spokes on the thermal relief. This is something that you can specify using custom rules. It won't show up in a DRC check, but it will show up when you do a zone fill, because the zone fill is where those spokes come from. Also, clearance override. So pad clearance, solder mask, solder paste, all of these elements are going to change what the output of your fabrication looks like. When we change these elements, these are changed automatically. You don't see this in a DRC check, because this is not something that you modify somewhere else, right? You modify it only here in the pad properties, for instance, or you can modify it in a custom rule if you want to affect a large number of pad properties. Now, some other things. In the copper zone properties, the vast majority is not going to give you a DRC check. So any of the shapes or the corners or hatch or type of fill, all of these things are modifying what the zone fill does when you refill the zone. You can set all of these parameters using your custom rules, but they are not going to show up in a DRC check. However, with the one exception here, that the electrical clearance will show up in a DRC check. So if you end up putting something too close to a copper zone and you don't refill, so that part is going to be very important. If you refill, the copper zone is going to take the clearance into account and provide the appropriate offset from the electrical item, from the copper item on your board that is specified here. But if you don't, DRC will still check it. So DRC is still going to catch if you move a pad or a trace too close to the copper fill and don't refill the copper zone before you run DRC. Then you'll flag a DRC. So that's why we have that one item in the copper zone properties listed as potentially a DRC error for you. Now, this part is important because when we talk about what this is going to look like in KiCad itself, we have a priority listing that gets overridden. So your overrides are going to change which ones in your, which parameters are taken as your true value. And that true value is for either DRC or for zone fills. So the bottom of this priority list, which means the one that gets overridden by everything else, are going to be the net classes and zone properties. So down in the bottom right here, you can see, well, right behind my head, you can see this copper zone properties. This is where you set the zone properties of the copper zone. These are the baseline defaults, and they are the ones that will get overridden by everything else. So if you don't have any overrides, this is what it's going to go with, but anything can change this. Up above that, solder mask and solder paste defaults. So these solder mask and solder paste defaults will override. So these are defaults for your board. Now this is the middle window here. This is in your board setup. So your board setup, solder mask and solder paste will override. Say you have a net class that specifies any of these elements. Solder mask and solder paste are going to override that. Then after this, then we get to the custom rules. So this is where you are writing the custom rules, and this is going to override anything below this. So override solder mask, solder paste, net class, zone properties, footprint and pad local overrides. So these are going to be when your footprint or your pad has a specific property associated with it. Now, if it has a specific property associated with it, you're going to have to go in and change that explicitly. And we respect the local overrides on the footprint and pad that you specify in the pad or footprint itself. The reason why we are going to take those as overrides is because by default, they're going to take the normal rules. But if you took the time to go in and change that for a specific footprint or a specific pad, then chances are, we assume that that is something that is required for the functionality of that footprint or that pad in any board that you place it on. So we want that to override. And then our highest priority is going to be the board setup constraints. These are the ones that get set based on your fabricator. So your fab house is going to have a minimum clearance. That should go in your board setup constraints. That minimum clearance is going to be the smallest amount of space that they are actually able to produce. And if you make it smaller, they're going to have to go to a different fabrication process. So you want to have some hard constraints based on your fabrication elements. Now, I will put an asterisk here on this because you can actually override this by having a custom rule that is narrowly tailored. So your board setup constraints are going to be this board level thing. But say, for instance, you need to have a neck down to actually connect a track to a BGA component that you can't fit within the normal clearance you have on the board level. Well, if you have an area-based constraint that is narrowly tailored, so you have those conditions set up to limit which ones are going to be targeted for clearance or copper width, these sorts of things, then your board setup constraints can be overridden by custom rules in this case, but in the vast majority of cases we do not. And if you want the full details, you want to say, well, does this happen, right? What are the assumptions that we are making in order to facilitate rapid development of your PCBs? All of these individual assumptions are documented in the KiCad documentation website, docs.kicad.org. And you can find all of these details there as well. This can help you to actually pull out individual cases when you're not actually sure which way this does go. We find that our heuristics here on which override happens where matches the vast majority of engineers' experience and expectations. So hopefully this matches yours, and where it doesn't, you can definitely override with a narrowly tailored custom rule. So let's talk about constraints. What can you constrain? So constraints set a tighter limit than board-wide constraints. So we're just saying, all right, we have these board-wide constraints. So let me go back one slide here. Top right-hand corner, this is the board setup, design rules, constraints. These are what we're talking about with the board-wide constraints. These are the constraints that we expect to provide a baseline for everything else based on manufacturer requirements. But we said, what happens if you need to modify that? If you need to set a tighter limit than the board-wide constraints, you can do that. You can bring that down to a tighter limit. You can loosen or tighten the net class constraints, and you can generate entirely new ones. Each of these here on the list, annular width, clearance constraints, connection width, courtyard, all of these elements here in the list on the right are different elements that can be constrained. And this list is for version 8. You will find a much longer list now for version 9 coming out in February. So look for that. All of these individual constraints are documented on docs.kicad.org. So the individual ones, if you want to know, well, what is the difference between a physical clearance and a physical hole clearance, if it's not immediately apparent, or the difference between a clearance and a physical clearance. Each of these things is well documented in the KiCad documentation. So please do have a look there and familiarize yourself with each of these as you are building your own custom rules. Just as a preview, clearance is an electrical clearance. So there you're talking about things that have voltage associated with them or potential associated with them, and you need to separate those potentials. Physical clearance is going to separate physically any two items that need to be separated on the board. So this can be silk screen needs to be separated from a pad. This can be edges, board edges need to be separated from a footprint. Physical clearance allows you to specify clearance based on the physical extent of the item you're specifying, not necessarily the electrical extent. So if you specify clearance, for example, for a pad, it's not going to take into account any of the non-copper layers in that clearance. It will only take into account the copper layers. But if you specify physical clearance for a pad, it's going to take into account the mask layer. It's going to take into account the paste layer, going to take into account all of the layers of that pad when it is calculating a clearance. So move on. These are each of the things that you can control on your board. You can make them tighter constraints. You can loosen the constraints based on any of the conditions that we'll cover later. Well, conditions. Conditions are limiting the scope of the constraints. So you want to have a clearance that only applies to pads with a specific net. Well, the net is a property, and you can specify the condition where the clearance only applies to pads of a specific net class, pads of a specific shape. Maybe you need to have a different clearance for your say you have a square pad, you want to provide a little extra clearance to the copper to make sure that you're not exposing the copper with a mask that you would not otherwise need to provide for a circular pad because you have some rounding on the corners. Each of these properties of an element can be included in the rule in order to limit where the condition applies. So when you have things with a single property, you're going to specify that property with an A dot property. Now, A is just a placeholder. You use A to specify the first element in the rule. And with a single property, so if you are saying that the property only exists with a single item, like the width of a line, or the boldface of text, or the the color of the line in your layout, each of these only exists with a single property at a time. It's not a relationship between the properties, and so there you will only have a dot property, and then a double equal sign equals the value. So double equal sign value allows you to set a condition there. If you have two properties happens when the property exists as a relationship between two items. So clearance is a good example. Clearance only exists as a relationship between two items, between a pad and a trace, or between a zone and a pad. You have a dot property, which is the first element in that property, and B dot property, which is the second element. So you can have a clearance that only happens when A.net class is equal to power and B.net class is also equal to power, for instance. So in that case, you can set a clearance between two items when they're both members of the power net class. Or any of these elements, if you have physical clearance, hole clearance, each of these are relationships. They're dual properties. And how you write these rules is you say a dot property, which is the first one, is equal to the value, and then a double ampersand, that's the and symbol there, b dot property equals. So you're setting two constraints, two conditions on your constraint. You don't have to switch these. So what I mean is that you don't have to cover the case where A is equal to a track and B is equal to a pad, and also cover the case where B is equal to pad and A is equal to a trace. Right? We will automatically cover both conditions when you write one dual property condition. So what are some useful conditions? Useful conditions can be areas. You want to have an area that provides a specific condition to your board. So this is a geometric limitation. So some of the best ways to do this, you can place the area on an eco layer or a user layer in your you make a non-copper area. These are called rule areas, and you can give your rule area a name. See, in the top right-hand corner here, we're calling our rule area no HV. And the basic rules here, keep out tracks, keep out vias, keep out pads, keep out zone fills, and keep out footprints. These are ones that we know that people like to use a lot. And we don't require that you write a custom rule for it. We just have some check boxes there for the rule area. If you're not going to require any of those, then just leave them unchecked. You can still make your rule and assign it your own constraint based on the area. So with a name in this rule, you can refer to it in your custom rules. So here, what we're doing is we're saying rule, and we give the rule a description because this is what we're going to see in the DRC check when it fails. So we want to know which rule we're checking. So this is no high voltage by connectors. So this is the name of the rule. And then we set up a condition, and we say that A, which is the first object, intersects area. So this is one property of A, intersects area with area named no HV. And so the double ampersand means and. We also require this condition, the second condition, A dot net class is equal to HV. So what we're saying here is that A, whatever A is, right? Whatever A is, A can be anything as long as it has a net class associated with it called HV, and it intersects with the area that we have defined, that we have named no HV. So this isn't going to, A will never apply to things like text on the silkscreen layer because they don't have a net class. It will also not apply to any of the copper elements that are not assigned to the HV net class. And finally, it won't apply to anything that is outside, fully outside of the area no HV. And then what do we do here when this is true? We set up a constraint. The constraint is just an assertion. And all we say is we're going to assert false. So what we want to have happen here is if this rule is true, so if the two conditions are met, we want to make an assert. And the constraint just says, if those two rules are met, assert false, and an assertion will pop up in the DRC check. So this is a good rule that you can place in your board and use to avoid accidentally placing any of your HV elements, high voltage elements, inside an area you want to protect from high voltage. So look at the difference here. We have two here, two rules. What are the two differences, or the difference? The first one says A intersects area, no HV. And the second one says A enclosed by area, no HV. So now these two are generally similar, but you're going to find a difference here in that the second rule will only trigger if the entire element with net class HV is inside the area. So you can make some changes here. Obviously, for our purposes, the first one makes a lot more sense because you don't want high voltage anywhere inside this area. But sometimes you will want to constrain the elements by being fully inside the area. So you want to check that. Now, always look for your overrides because custom rules can be overridden by pad local settings. So where are the pad local settings? You go into the pad properties, then under connections or clearance overrides, you'll see the local settings to the pad. And these are settings that are controlled by the pad itself. So why would you want to do this? You want to do this because you're designing a pad that has a specific requirement, or you're designing a footprint with a pad that has a specific requirement. This pad always needs to be always needs to have a solid connection to the zone fill. It can't have thermal release because of the requirements of the internals of the footprint. And you know this to be the case. So in your footprint design, you set up these overrides. These overrides will not be changed by custom rules. So if you need to change a pad property that has an override, you're going to need to modify the override because of that priority levels that we saw, because of the priority levels that we saw earlier. So here, how would you know that your pad has an override? Well, here we say, if you want to make sure that your rules are the end story on your board, then you can make a rule that actually checks to make sure that your rules are the ones that are being applied. And the way that you do this is you are going to assert. Again, the constraint is going to be an assertion, and you're asserting that something is true. You're going to assert that a.zone connection style, one of the properties of a pad, is equal to inherited when a.type is equal to pad. So if that assertion is false, it will raise a DRC error. If the assertion is true, then nothing will happen. So if your pad connection style is inherited, then you won't see anything in the DRC. And if it isn't, then you'll see an error, and that will flag for you as the board designer that maybe your footprint designer, or maybe that footprint that you found online somewhere, isn't doing exactly what you want it to do. So this kind of rule can save you a little bit of headache trying to figure out exactly why the custom rules aren't working the way you expect them to with some footprints. Now, what would you want to use? One of the ways that you might want to use a DRC rule. So for example here, you might have a variant design where you have two footprints that are overlapping, two components that might be overlapping in your design, and you want to allow this to happen. In this case, we have two potential oscillators, both being allowed in the design, and normally DRC would flag this. And the reason it would flag this is this purple outline here that you see on the screen is the courtyard. Overlapping courtyards are a big no-no in KiCad, and by default will be flagged by DRC. But we want to tell the DRC that in this case, this is actually okay, because you want to fabricate a board that you can make a field choice later with to swap which oscillator you choose for your design. It's easy to do with a custom rule. Very simple, allows overlap. You set the minimum courtyard clearance to a negative value, right? It can be any negative value, but -1 millimeters. That says that if two elements, one has do not populate and the other one is not set to do not populate, then you're going to allow the courtyard clearance in that case. So in your default variant, you're going to set one as a do not populate. So this is saying don't worry about that courtyard overlap in this condition. Allows you to pass your DRC checks while still maintaining the knowledge that you are not missing appropriate DRC checks. How about footprints? You want to keep them away from edge cuts. So here, where we're saying we need to actually keep footprints away from the edge of the board for fabrication reasons, or perhaps for usage. So you have some limits on where the footprint can be placed on your board. You want to actually codify that into your board itself to make sure that your design maintains the limit that you're set. In this case, this is a condition that exists between two objects. And the first object, if the first object exists on the courtyard and the second object exists on edge cuts, then we want to have a minimum physical clearance of at least 1 millimeter. You can pick whatever you like here, 2 inches, 4 inches, setting the physical clearance constraint. Again, physical clearance here because these are not electrical elements. The courtyard layer is not electrical, and the edge cuts layer is also not electrical. You can set these here to force you as the designer to remember to keep your footprints at least a specified amount, a specified distance away from the board edge. And again, you can set additional conditions here if you want them 2 inches away from the edge cuts on the sides of your board, but only 1 inch away from the edge cuts on the top and the bottom of the board, for instance. These are additional conditions that you can set. You can use it using area, using areas that we saw earlier. You can draw your areas around where the edge cuts is and specify them that way. And you can also change, limit them based on the properties of the edge cuts lines themselves, of the edge cut elements themselves. Another example, non-plated holes inside surface mount devices. So this is usually a DRC error because you don't normally want to put a non-plated hole inside a surface mount device. However, in some conditions, you might want this crazy layout. We've had customers who are looking to create a mounting hole that doesn't have electrical connection to the bottom of the board, but still exists on the surface mount device itself. This is a very unusual condition, but that's exactly what the custom rules are there for. What you want to do in this case is to say, well, create a rule, non-plated through holes allowed, right? This condition, A intersects courtyard with L2, you're specifying which footprint you're going to allow here, and then you're going to say A dot parent is equal to B dot parent. Now, what are we doing here? We're saying that this non-plated through hole exists as an element in the footprint itself, and so does the surface mount pad. Both of these exist as elements within the same footprint. When this is the case, we want to disable the hole clearance. So hole clearance is going to be what we are usually looking for in this. This is what is going to fail. The hole clearance is too close to the pad. Disabling that DRC error is exactly what you're looking to do here. Now, another option, you want to make sure that your silk screen is not overlapping masks. This is a basic check here, because we're not going to adhere to copper. So in this case, you want to look for silk over masked areas. Now, this is a earlier version rule. As we have developed these rules in KiCad, we've found that many of them make a lot of sense as default rules, and we've brought them into KiCad themselves as DRC checks. We've done that with the silk mask overlap, for instance. However, in this case, if you want to move the silk further away than the default KiCad rules, then you can set your constraint higher here. You can set a minimum silk clearance between anything that exists on layer with a name starting with F, and B exists on a layer F mask. So here, what is A going to match? A is going to match anything that exists on a layer starting with F. Well, we're only looking at silk clearance, which means the only thing that is going to be matching are going to be those elements that are on F silk, which is the name of the front silk screen layer. We don't have silk on any other layers, so A exists on layer F star is going to match everything starting with F, but there's only one layer that has a silk clearance. So this only applies to the F silk layer. B exists on F mask. There, we're looking for a specific bit of information. If there's overlap between an element on the mask layer and an element on the silk layer, and they're both front layers, then we're going to raise a DRC error. Similarly, back silk over a mask layer, we get a second rule there to set up the same constraint on the B silk and B mask layers. Now, we went over a few rules, but there are lots of them in KiCad. And the example rules are a great place for you to start when you are building your own rules for KiCad. Now, they are in the custom rules window. So if you go to board setup, go down to custom rules in the on the left here, and then look up in the top right. You see that there's a syntax help item. We put them there so that when you're writing the rules, you can click on that and pull up a little help window that gives you basic ideas. So in the beginning, on the top of the syntax help, we have the top clauses, the rule clauses, constraints, conditions. If you want examples, you have to scroll down. So let's scroll down. No, keep going. Keep going. A little bit more. There we go. Basic rules. We get to basic rules at this point where you are specifying differential pair gaps, clearance between A and B. These are each of these provide general ideas for common rules that you might want to include in your custom rule set. You want some advanced rules, keep going down a little bit further, and you'll see some of the more advanced techniques that you can use in KiCad when you are setting up your design rules. So with that is the end of our presentation on KiCad's design rules. I'm happy to take any questions if people are interested in any element of this?
We can keep the Q&A for the end, and while Amit prepare his slides, I'm going to launch very quick poll, another one. Just 2 questions this time.
I will stop my share then.
You see my window?
Yes.
Okay. Seth, while people are doing that, you said something which I wanted to ask you about. The non-plated through hole inside the SMT in the SMD pad. For us as a manufacturer, that is a VN pad that we have to plate over in order to assemble properly. What can the user do for that? Can they add those to a drill chart relatively easily? Is there any automation they can do there, or because a lot of customers
Right. So I would be surprised if those were able to be plated, to be honest. The non-plated through holes, there shouldn't be really anything to adhere. So I guess unless maybe you're filling it with epoxy or something, but that in this case, what the designer wanted was they wanted the ability to attach an element to the backside of the board and have it soldered on the front side, but not have any copper exist on the backside. They were designing a single layer board, so they did not have any plated through holes, so that wasn't a process that they were working on. In order to allow for fabrication, the paste mask for the SMD pad was split so that there was a gap that split across the hole. Because it's not plated on the inside, there is limited solder wicking that happens, and you generally don't end up in that case with a with an underplated pad. Now it's not to say that it couldn't happen, and I know you're definitely the expert on fabrication processes here, but this was chosen as an example because it was one of the strangest requests that we had seen in terms of, can we do this?
Right.
And it's not something that I think you would commonly see in a manufacturing process, but that's what the custom rules are there for. They're there to accommodate the uncommon.
Yeah, no, absolutely. So one more common scenario is that same thing. It's an SMD pad, so a surface mount pad with a surface mount device and a drill hole inside the pad. Whether you're going to plate or not, I guess doesn't matter.
Yeah.
So that
right. Well, so
that's
I think that's exactly what they were looking for there, right? You have a non-plated through hole. It's a drill, basically a drill hit on that pad.
okay, got it. And all these, and this is just for my education, all these rules that we're talking about, they're real time.
So any of the rules DRC check is a step you take after you have designed a portion or all of your board. While you are routing, for instance, DRC clearances are accounted for. So that is a real-time check while you're routing, and you will see the errors pop up when you violate one of those rules during real-time routing. However, when you are, for example, placing a silkscreen item that violates the clearance to the edge of the board. For instance, if you have a DRC custom rule or a DRC rule that specifies silkscreen offset from the board edge, that is not going to be real time. That will be something that is caught by the DRC check and highlighted to you as part of your design process.
Got it. Okay. All right, great. Thanks for explaining that. Okay, so I guess I'll go through what I'll be talking about. And again, people from the audience, please ask questions. I always enjoy that. Whether we can answer them or not is a different question, but we have good experts here. So ask away. So these are the topics that I will be covering fairly quickly. So I'm going to start with number 3, ray tracing, signal integrity, component placement, etc. All right, so the benefits of ray tracing. So it's fairly straightforward. You can make sure there's enough, spacing between components, solder mask clearances. You're getting, any overlapping features as we were discussing earlier. So you can get a good kind of visualization of your board. You can rotate and zoom and all that stuff. So it is more visual. I think there's no kind of constraints or error checking here, if I'm not mistaken. So it is very visual, but visual is still a good idea. So how KiCad can help with your signal integrity analysis. So in KiCad, you can get precise control over your track width and length. And so when you're designing for impedance or high-speed signals, this is, a really key capability. You can do interactive length tuning and length matching of your critical traces. And KiCad can export to tools like SPICE. So there's some good tools for signal integrity analysis within KiCad. And if you need tools to calculate your loss or your impedances, Sierra also has some great free tools on our website. Seth, would you add anything in terms of signal integrity, either routing your traces or the analysis?
Yes, without a doubt, you should definitely take advantage of length matching rule sets in the custom rules, skew matching rule sets in the custom rules. If you're dealing with differential pairs, you can set all of these constraints based on net classes, based on groups of signals, net names. All of these elements are controllable in your custom rules and definitely should be addressed there before you start designing. That would be the other key thing. Set up your rules, make sure you know what they are before you start designing, because it's always easier to design well than to have to rip up and rebuild after you've gone too far down one rabbit hole.
Thank you. So I was gonna kind of segue to component placements, and I know we were talking before the webinar, so I'll probably lean on you again to talk about component placements. But basically, the super critical part of the layout process, you want to make sure that you provide that you think about your component placement in terms of EMI, EMC. You don't want to have critical traces routing across your whole board. So you want to place components that provide similar functionality close to each other. So that's something that as As a designer, you would learn through experience. But yeah, super important topic, and we cover that a lot in our EMI, EMC type webinars. There's some other key points here, like aligning your connectors with the respective nets. Very important in designing your component footprints to have a properly designed courtyard around each component. So this will ensure manufacturability of the design in terms of assembly and pick and place, and even allowing access for flying probe test. So we're stating here we'd like a minimum of a 10 mil courtyard clearance. Seth, do you have any comments on courtyard clearances or how to design them?
Absolutely. When you are designing your footprints, KiCad really likes you to put down a courtyard on the footprint. Your front courtyard can be different from your back courtyard in the case of through-hole components or components that require, for example, thermal standoff to other elements. But you need at least one courtyard, fully enclosed courtyard, in your KiCad footprint if you don't want to get a DRC error. KiCad will yell at you in the DRC process if you don't have a courtyard for your footprint. Here, Amit has called out a 10 mil courtyard clearance for the courtyards. You can accomplish this in one of two ways. Either you can design your courtyard with that 10 mil spacing. So you're going to set 10 mil off from the nearest element. So you just kind of draw that polygon or that circle or that rectangle with 10 mil to the nearest element. Or if you have close cropped courtyards, then you can specify a 10 mil courtyard clearance in the custom rules. So you can do an offset there in the courtyard in the custom rules, where you test one element on the courtyard layer against another element on the courtyard layer. And there's an example of that in the custom rules.
Okay, great. Thank you. So, we have just a couple more points, which is placing components near the board edge. So we'd want, let's say, 50 mils of clearance away from the board edge. And this is good for handling, and you don't want to damage components that are too close to the edge. And we've seen some root cause failures in the past for components that are close to the edge, and you have breakaway tabs really close to that component. If you're using any force on the breakaway tabs, that could cause a damage to the board / even lift the component. So having a good clearance from the edge of the board, if you can, great. And if you can't maintain that, don't have a breakaway tab there for any extra mechanical force in singulating your boards. So I think that's a really important one where I've seen some root causes there. And then a couple more pointers about, where to place your components. And again, we have other webinars and resources that really go into detail about proper component placement. Now I'd like to lean onto the Sierra team to do a demo of our quote process. That we have built a plugin within KiCad that would help with that, to make the quoting easier, because I know quoting also always can be a little bit cumbersome. So we have someone from the Sierra team who can do a demo of that?
Yes, Amit, I am here.
Okay, great. I'll stop sharing.
Okay, let me start. So I will start with the installation process, how to install the Sierra plugin in KiCad first of all. So you need to open the KiCad you need to go plugin and content manager from there. Okay, so once it will open, you need to search for Sierra plugin. You can see it here. From here, you can install it directly. Once installed, you can open any of the design file. And then from there, you need to enable the Sierra plugin so that it will show on the home page. For that, you need to go to preference, then again preference. From here, action plugins. From here, you will see the Sierra plugin will listed here. You just need to check this box and click on OK. It will show on the home screen itself. As you can see here, top right, you can see here the Sierra plugin logo is there. So from here, you can directly open our plugin. Here we have given two options. If you have already registered with us, you can use your credentials to log in. If you have not registered and want to proceed without that, you have option to continue as a guest. You just need to enter your email address here to proceed further. So I'm using right now the guest option. So once you logged in or proceed from the login page, you will land on our home page, which is board geometry page. On this page, you will see so many options like dimensions, quantity, layer, thickness, and all. You have option to change the quantity only and thickness. Other things are disabled, which is fetched from the design file. The other tabs are also board clearance, which is fetched from design file, holes also. Surface tab, you have the options to make the changes for silk screen, solder mask, and surface finish. Finalized tab have electrical testing for up to 6 layer. It is optional. Above that, it is mandatory. So once you are satisfied with all the details, you just need to click on validate to validate your design file. So based on your design file, it may take some time to validate. And if any error will be there, it will show here the error message. If there is no error message, only non-critical details warnings are there, it will show like this. As it is a non-critical, you are good to go or proceed further to create the code. So now after clicking on OK, click on get code to generate the code. So as you can see, it's a Sierra Circuit online code. You will see here by default, it is 3 days and 7 days for us, for you. And the quantity which you have opted for or provided on the geometry page, it will show here like by default, it is 3, 6, 9, and 12 days. So based on your requirement, you can select the quantity and turn time and then click on OK, which will land you on the web page. So you are on the web page where you can see left side modify code and right side the code summary section. In the code summary section, you can see the design image, which you can verify by mouse hovering. In the modify code section, you can see if you expand it, you can see quantity, turn time, electrical testings are there. You can modify the quantity and turn time here based on your requirement if you want once again. And the option is to add the assembly also, it is there below. You just need to click on yes. Then it will show checkbox to check mark. So I'm going with assembly. And then click on continue, which will show a pop-up message that would you like to generate a auto-generate the BOM, or would you like to go with PCB only flow? So right now I'm going with PCB plus assembly flow. So I will click on generate BOM, which will land me on the BOM builder tool. Here, it will auto-generate the BOM and show from your design file. So if you want to modify any of the line item here from auto-generated BOM, you can do, or else you have the option to upload a custom BOM. from this button, you can upload that. We have the sample Sierra format BOM also here to download for you, which you can do and modify that to upload. So I will go with custom BOM right now. And we have enabled only local computer right now to upload your BOM. So I will upload a custom BOM. It will open the BOM column mapping here. If it is not mapped correctly, you can map it by manually. If it is mapped, well and good. So I'm just mapped a couple of line items manually. Then click on proceed. So as you can see, I have uploaded custom BOM and it shows 3 line item errors. So you people have the option to fix those line items, or you can delete also or mark it as DNI also. So I will show you 1 or 2 line items how to fix it by clicking on those line items. So it is invalid quantity 0. So the reference designator is 1, but quantity is showing nothing. So I just will provide the quantity and then click on save. So it will validate the line item and then it will show, if it is correct, it will show the correct line item here. As you can see, the line item number 1, it is corrected. Same way, if it is showing invalid part not found, then you need to click on fix button to fix that. Then we have the option for search assist, value search, MPN or VPN search, or description. So all these searches, you can search the component and add in the current BOM. I will go with MPN or VPN search here. I will just make some changes and search for only using MPN. So while searching with MPN, I can find the components here. I will select one, which will show me the search assist to compare the old part details with the new one to proceed further. So I proceeded with the new one. So this also corrected. One line item I will mark as DNI or delete anyone. I can do that. I will mark as DNI. So now you can see it is showing your BOM is ready to continue. After navigated from the BOM builder page, you will land on the code page. Here you will see again 2 options. Right side you will see the code summary for PCB plus assembly. On the left side you will see the options to modify for PCB quantity and turn time, and assembly quantity and turn time. Both you can modify here. Based on your requirement, you can make the changes here as well. If you do not want, you can proceed further. So from this page, as I have continued, so as a guest, here it will ask me to log in to continue from this page. So I will log in here. After login, you will land on order details page where you need to add the address for billing address, shipping address, and designer address. Once address is added, you will have the option to select the shipping method. And below that, the tax and resale info is there. Right side, you can see the code summary for all the details till now, whatever you have given. And below that, the payment option is there for credit card. You can enter the credit card details and make the payment. I will use not authorized. If you are not authorized to make the payment, you have the option to send the link to someone else to make the payment. So I will use that option. Once check mark is selected, you can see the pre-filled details are there. You have option to modify these details. If it is correct, you can proceed with that by clicking on agree button and click on review order, which will land on order review page to review whatever the details you have given till now. After reviewing, below you can see PCB plus assembly specifications also you can see here. If you are satisfied with all your details, you can click on place my order to make the order. So as you can see, the order is placed, and as I have used the option to make the payment by someone else, it will show at the top that this order is now placed with pending payment info. order will not start until payment is finalized. So make sure if you are sending the link to someone else to make the payment, inform that person to make the payment so that the order will start processing. In this page only, below you can see the options for the notifications. If you want to send a notification to someone else for the different kind of jobs, you can add the person email address, name, and phone number to send the notifications here. From this page only, you can see, you can go to our customer portal, and at the top you have the link to track the order. What is the status of the order? You can click on this link to track the order. That's it. This is the way you can place the order using our Sierra KiCad plugin. Thank you.
Thank you, Naveen. Okay, so do we have any questions?
We don't have any question. I don't think we have any questions. I just wanted to say one thing. I give a shout out to KiCad for implementing the 2581 in KiCad as a native output. And I would encourage, all the people in the KiCad community to use 2581. Do we have that somewhere? Yeah. And here's some references to our blogs on 2581 and using KiCad to output 2581.
Okay, great. I will send everyone the slides and recording this afternoon, so they will be able to see the blog.
Yeah, that would be great.
We have a question in the Q&A. Okay. Seth, you can answer live if you want. You don't have to type.
Sure. So the question is if there are any plugins that we suggest that you should have or top ones. So I assume that this is asking in addition to the Sierra Circuits plugin. I'm not sure. I'm just guessing, Amit. So the plugins are going to really depend on what you're trying to do with KiCad. There's some great plugins out there. The interactive bomb plugin is a really good one if you are doing hand assembly, or if you are trying to debug a complex board. That tool can be really helpful. Additionally, there is a plugin called KeyVar that implements variants. So if variants are something that you're interested in, that is currently available as a plugin. There's a wonderful presentation from the KiCad Conference Europe in 2024 by the developer of KeyVar. And there he goes into great detail on exactly how to use and some of the interesting aspects of KeyVar. That will be available on the KiCad YouTube website in the next week or so. We're currently publishing those out. If you're interested in seeing more about what people are doing with KiCad, the KiCad Conference Series is a great way to meet plugin developers and find out how other engineers are using KiCad and the plugin ecosystem to be more effective in their jobs. So we'll be having a KiCad conference in the United States in San Diego next year, and you can find more details at keycon.kicad.org. That's keycon, like KiCad conference.kicad.org, or on the main KiCad website. We'll have some links there as well.
Okay, that's awesome. Yes, I remember attending one pre-COVID. It was a lot of fun and learned a lot. So great. I'm glad that we're having another one that is closer to home. So great. Well, Seth, thank you so much. And Wayne, thank you so much for doing this webinar, and look forward to seeing you guys again.
So I think we have one more question here. Is there a way to see which rule, constraint, or setting failed its test during a DRC? Yes, the best way to see which one is to make sure to give every DRC rule a unique and descriptive name. So let me see if I can pull up. I'll see if we can just share. Am I still able to do that here? Share a screen. Presenting. There we go. Okay, so we're going to go back here. So we'll go to here. So in this example, you see right after we say rule, we have this string, no HV by connectors. Now, what this is this is naming the rule. It's completely optional. You don't have to have it. But if you do have it, when you run DRC and this rule fails, DRC will show you this rule fails. And it will point to, there'll be a red arrow pointer on your board saying this is where the rule failed. But definitely give a descriptive string, and you can put whatever you want in this string. It doesn't have to be English, doesn't have to be anything in particular, just needs to be enclosed in quotation marks, and you can use that to remember which rule it was that is failing. So if that hopefully that answers the question, but if not, do feel free to ask a follow-up. Okay. We have another one. Could you explain the advantages you consider from KiCad if you are trying to implement it in your company against Altium? So I don't think that we have a particular advantage. So Altium and KiCad are pretty complementary in terms of the engineering ecosystem. And I say this deliberately because we try very hard at KiCad to implement as close a compatibility, the ability to open files and libraries with Altium as we can, to allow engineers using KiCad to interact effectively with their engineering partners or friends or colleagues who are using Altium. KiCad has different priorities than Altium. And if our priorities overlap with your company's priorities, then I think KiCad's a good match. Our priorities are that the software, KiCad software, is yours. It's not ours. We don't control it. When you download KiCad, it's yours, and it's yours forever. And that's part of our license and part of our ethos, how we build the organization and how we build our companies around KiCad are in order to give the engineers using it the most control over their designs. So you can share your designs with anyone you want, and they can always open them because KiCad is available to everybody. If you are designing products that are meant to have longer lifetimes, 20 years down the road, KiCad that you design your product with right now, you can store that KiCad directly with your design. KiCad is not a large program. So we have clients who every design they make, when they go to production, they take KiCad and the design and zip them up together and store them together. So if they ever need to go back to support the customer, to do field engineering, and they need to look and see what that design actually was at the time of production, they're always able to do that because they have the actual program that was used to create it stored with the actual design, rather than opening a design from 20 years ago in whatever the program is that exists today. So that's one advantage. Second advantage is no one can acquire KiCad. So what we are as a company, what we are as an organization, our focus is on the empowering the engineers who use KiCad to be more effective in their jobs and to design circuits more easily and more effectively. So with that mission focus, we are not attractive to third parties as an acquisition target. So you won't see KiCad being acquired by another company and having rules changed. So if that stability over the life of your company is attractive, then KiCad might be compatible with your organization. But there are many organizations for whom Altium is the correct choice, and we don't see ourselves as taking over that space. We are complementary to Altium, and we like them to succeed, because when we all are successful in serving our markets, then the entire EDA ecosystem benefits. Then we have more people who are designing boards, more parts available, more fabrication companies providing the services that we need to accomplish our jobs. If we're all siloed into one EDA, into one production fab, into one chips supplier, then we are all vulnerable. And I think we saw that really strongly during the COVID-19 pandemic, when a lot of those supply lines collapsed, and we saw just how vulnerable we were to single source elements and to dongle-based software and things that would limit our own freedoms. And so providing a broad ecosystem is the end goal of the KiCad project, and I hope that that matches up with what your company is looking for. So let's see, we have another one here. Is your contact info included anywhere in the presentation? My email is not included in the presentation. However, at the bottom of the presentation, you will find the website address for my company, KiCad Services, and you can go to the website, and there's a contact form there as well that will get you in contact with our company, and we can, if you're interested in any of the services we provide, training services, custom design services, or transition services, we can definitely help you out. So please take a look at the website and contact us there. Last, we have a question. Are there any plans in the future for KiCad to have ECAD, MCAD collaboration? We're actually working on this right now with a similar project called FreeCAD. This is a CAD modeling tool that exists in a similar freedom-based license that KiCad does. FreeCAD is currently under development, and they're with their overarching company called Ansel. And this tool does have very close integration with KiCad through plugin interfaces called KiCad StepUp. So this allows ECAD and MCAD collaboration directly through a plugin layer. We also provide step export. We've had step-based export from KiCad for over a decade now, and this definitely is useful. Many of our MCAD collaborators find this extremely useful for fitting and verification of designs against 3D models. We also have an IDX based export. However, we don't have at the moment import, but if that's something that is particularly useful to your company, we'd definitely be interested in discussing what would be needed to implement that. And if you're interested in having us implement that for you, we're available for that kind of work. So I think that's the open questions. If there are any others, we'd be happy to answer them, but I don't see any extra at the moment.
Yep, looks good. Okay, well, that was a much longer webinar than I thought it would be. Okay, thank you so much, Seth and Wayne, for joining. Thank you, Amit, for presenting. Thank you, everyone, for being here. And have a great day, everyone.
Thanks, Lucy.
Thanks, Lucy.
Bye-bye.
Bye now.